Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
Dad, why is the robot's arm up?
Because this diagram makes no sense, boy.
Well, it looks funny.
Funny? I can't even follow it. This diagram is just impossible.
Maybe you're looking at it upside down?
Hey my friend, welcome back to Web Accessibility for All. Ariel here, software engineer, web accessibility specialist, and your host. Yes, this is part 3 of our mini-series on accessible visualizations. And today we're diving into diagrams and graphs. They are meant to explain ideas, but too often they just confuse.
What's the difference? Graphs versus diagrams.
Graphs and diagrams. Yeah, sound similar, but they are not the same thing. Let's start by clarifying what makes them different from each other. Graphs are tied to data. They are numbers turned into relationships you can see. Picture a network graph where dots and lines show how people are connected. A diagram, on the other hand, explains structure or process. Think of a subway map, or even an exploded view of a Lego set. They all explain how parts fit together, or how a process flows. Graphs show data connections. Diagrams show conceptual or physical connections.
The glance factor, a cited advantage.
One of the biggest challenges with both graphs and diagrams is what I call the glance factor. A sighted person can look at a subway map or a network graph and instantly get the big picture. With just one glance, their brain gets relationships, shapes, and clusters. But for a blind screen reader user like me, there is no one glance. Instead, I have to mentally assemble the pieces of the puzzle one by one. And that exploration creates what's known as cognitive load. Now, here's where things get even trickier. Graphs and diagrams don't come in just one flavor. Each type creates a different accessibility challenge. Think about flow charts, diagrams that show steps in a process. Or consider hierarchical trees, like org charts or family trees. And don't get me started on Venn diagrams. Overlapping circles are great for showing relationships, but a nightmare to convey linearly.
Beyond the visual, the real problems with diagrams and graphs.
So, when you step back, the accessibility problems with graphs and diagrams start to pile up.
Navigation.
These visuals are built for quick scanning with your eyes, but screen readers don't scan. They read in a straight line.
Structure and relationships.
Graphs and diagrams rely heavily on spatial cues. Left, right, above, below, overlapping, and so on. Without extra markup or thoughtful descriptions, that spatial meaning gets lost.
Cognitive overload.
Even if we provide text alternatives, dumping every node of a network graph into a long list doesn't help anyone. It overwhelms users instead of clarifying. And the bigger it gets, the more complex to structure its parts.
Interactivity.
Many modern diagrams aren't static pictures. They are clickable, zoomable, filterable. Each of those features can empower users or lock them out completely if not built with accessibility in mind.
Crafting descriptions, a practical guide.
In practice, writing descriptions is one of the hardest parts of making diagrams and graphs accessible. There's no single official recipe, but they are converging practices from the WCAG, the Diagram Accessibility Research, and organizations like Diagram Center. A practical approach looks like this.
Start with the purpose.
Why does this graph or diagram exist?
Before details, tell the user the story it's trying to convey.
This diagram shows the steps in the hiring process at our company.
Give an overview first.
Much like sighted users can glance at the whole picture, non-sighted users need an initial sense of structure. For a graph,
There are 12 nodes grouped into 3 clusters, connected by directed edges.
for a flowchart,
It begins with a start node, branches into 2 decisions, and ends with 3 possible outcomes.
Drill down systematically.
choose a consistent reading order, often top to bottom, left to right, or levels of hierarchy. Describe nodes, connections, and relationships in that order.
Designing for everyone, universal principles.
We can bring in inclusive design principles that apply beyond just disability access.
1. Make it scalable.
A giant process? Break it into smaller linked diagrams instead of one spaghetti monster.
2. Provide multiple representations.
Offer a simplified overview and then allow users to drill down for details.
3. Use consistent symbols.
Don't invent your own icons. Cognitive effort skyrockets when people have to decode unfamiliar shapes. Stick to widely understood ones. Diamonds for decisions, circles for start or end, etc.
4. Enable search and filtering.
Let users find a node or path instead of forcing them to scan the entire diagram.
5. Add interactive orientation feedback.
When users move through nodes with the keyboard or screen reader, always tell where they are in the structure and what options are available next.
6. Design for small screens.
Responsive layouts should gracefully collapse into linear, list-based alternatives. Ben Schneiderman, one of the pioneers of information visualization, has a famous mantra that fits perfectly here.
Overview first, zoom and filter, then details on demand.
From idea to code, building accessible diagrams.
This is the heart of the problem. Let's unpack it step by step.
How diagrams usually appear on the web.
Most diagrams and graphs today end up being raster images exported from Figma, Visio, Lucid Charts, etc. They are totally static. need alt or long descriptions. SVG, scalable and searchable, but often exported as a single blob with no structure. Still read as
graphic
by screen reader, unless tagged carefully. Canvas or WebGL, used by libraries like D3 for interactive diagrams. Screen readers generally see
blank
unless developers add parallel accessibility layers.
More accessible HTML approaches.
If we step back and ask, what's a diagram? At its core is a set of nodes and relationships. And HTML can represent that if we model it explicitly. For example, lists for hierarchies. Screen readers announce nesting naturally. Order list for flows, good for linear processes. Tables for connections, good for graphs, adjacency or matrix representation. ARIA plus SVG hybrids. You can keep the diagram visually in SVG, but annotate with ARIA attributes and provide a parallel DOM structure that mirrors the relationship. This is a current best practice when diagrams must remain visual.
Navigation.
Unfortunately, WCAG doesn't tell you how to make diagrams navigable. In an inclusive design, users should know where they are, how many elements exist, and where they can go next, just like in a multi-step form. Without that, a big diagram is nothing more than spaghetti, whether you can see it or not. For real orientation, we need keyboard navigation model, arrow keys to move between nodes, tab to step through connections, enter to expand the branch, announcement of position.
Node 3 of 12 connected to Node 5 and Node 6.
Overview shortcuts, a key to jump back to root or get the summary. Search, let users type a node name and jump straight there. Position cues.
Currently focused on Node 7 of 12 in the second cluster.
Hierarchical breadcrumbs.
You are in the marketing branch, right pointing arrow social media subbranch.
Final thoughts.
Graphs and diagrams are like puzzles, asking us to piece together the story from the data. By creating inclusive diagrams and graphs, you are not just adding a checklist feature. You are building a bridge. You are making your ideas more accessible, more digestible, and more powerful for all viewers. When you simplify for one, you improve for all. Thanks for joining me on Web Accessibility for All. This has been the third episode in our mini-series on accessible visualizations. Stay tuned for our final episode. Remember, data is only as powerful as the number of people who can understand it. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.